So we're gonna take a look at our working prototype right now. So this is, as you can see, the dashboard of Azura's Smart HVAC, and we have a lot of features here. We can check through the office atmosphere, which shows the number of people on this floor and humidity. Let's go in here. So we can see the population on this floor, and we can see the increase and decrease in the last hour or day, as we can see in the rest of these things. So we have humidity, average floor temperature, air pressure, CO2 levels, volatile organic compound levels, and PM5, PM2.5, and more. And we can also see recommended values for the changeable quantities like humidity and average floor temperature. So another feature that we have is building control. So we can control lights, doorways, speakers, and broadcasting, and also the power. So in the light section, we can control the lights for each area in, let's say, your office or your floor. So let's say, so and then this walk-in feature, by enabling this, whenever someone walks into your area, this reception area, let's say, the light will turn on or get brighter depending on its current state. And we can also, depends on the light, but we can also change the color of the light from right here on this dashboard. And we also have a master switch here, which will effectively turn all the lights off or on. And we can also see the power usage for just the lights, and we can see them for each light separately, and this is the power usage over the day. And let's check out the doorways section, and these are the different gates and doors on this floor. And we also have the master lock here, for which you need to enter a pin to activate. This will automatically lock all doors, and you can see which doors are locked or closed or unlocked or open. And in the speaker section, we can control the broadcasting of audio. So this can be for general broadcasting, for alarms, etc. You can speak through a mic, or you can play an audio. So this can be an alarm, or just general music, general purpose music, etc. We also have audio signage for the visually impaired people, and by enabling this, they can be led to directions through this audio-based signage. And we can control the speakers for each section, like we control the lights, right? And we have the power section, where we can monitor different solar panels and batteries. So we can see the status and health of the solar panels, and the activity of these batteries, and their health and their usage, and how much capacity they have left. And this is also master switch for emergency power shutdown. And this graph here, it shows the power usage of the whole building during the time of the day, and these metrics are controllable. And we can see here that we are on this particular floor, so this is the dashboard for this floor.
Hi everyone, welcome to Azura, the smart solar-powered IoT hub for smart homes and devices. The features of our project include smart solar-powered IoT devices, which can be used to power HVAC systems and also home automation systems. We have the ability to gather a lot of data, and we have multiple features, including touchless interfaces like remote control IR, a mobile app, and we are able to expand to using voice input as well. Our sensor suite has multiple sensor arrays, including air quality sensors, which can detect PM 2.5, 10, 5, as well as carbon dioxide and volatile organic compound levels, whether doors or windows are open or closed, levels of light, people's occupancy, temperature, humidity, etc. We can also incorporate audio signage for visually impaired, and sound or alarm broadcasting to specific areas. The advantages of our system are to allow optimized power use of home automation devices. We can automatically conserve power depending on the battery levels of our solar powered system. Potentially, this will lead to lower utility bills, as well as more optimized service life of components in the HVAC system, like your AC, compressor, vents, etc. We also have the ability to power down certain parts of of your home where there are lower number of occupants, as well as optimize for power savings whenever the battery level reaches a certain number. Next. The technology we used on our hardware side, we had a Raspberry Pi as a device hub. And we had an Arduino Uno as a controller hub for various sensors as well as motors which emulate fans. We use the Azure IoT hub for telemetry from devices, as well as performing control functions, as well as updates edge devices. For our mobile app, we use React Native. We wrote Python for backend services, and um, we used Cosmos DB for storage of values we got from telemetry. So here's a close-up look at some of the hardware components that we have on our system. So the first one is a buzzer or a speaker that allows us to use audio signage or alarms or systems. Second one is a light sensor. So this kind of tells you what the lighting levels are in certain areas. The third one is the Uno microcontroller that's used to as a device hub. And then we have a DHT11 that takes in ambient temperature and humidity. Next slide. This is a receiver for IR signals for remote controls, and this allows our system to be controlled via a remote control or IR. This is another light sensor. Here are the solar panels, which are then connected to our LiPo batteries, and also in the picture you can see the charging circuit. So this kind of enables us to, one, regulate the power collected by the solar panels and charge our batteries, as well as give us the level of the charge remaining on each of our batteries. The picture on the left is a distance sensor, which allows us to know if doors and windows are open or closed. This essentially is an ultrasonic HCSR04 distance sensor. Next is VOC, an MQ series VOC and carbon dioxide sensor. So this allows us to detect carbon-based organic gases in the environment. And finally, we have an air quality sensor which detects particulate matters like PM1, PM 2.5, PM5, and PM10. Here's a picture of our setup being charged, and then we're basically able to work with our charged home automation system. So this does not require external power, and we are able to control all these different sensors and devices using the solar-powered setup that we have.
All right, we are now outside and we are charging our battery from the sun using the solar panels. And yeah, we can see the LED. All right, cover it. Cover the first one.
This one?
Yeah.
Yeah.
Okay. And the other one? Yep.
So this is a web dashboard for our smart HVAC system. You can see various parameters for your building on the screen, such as people on your floor, air quality, temperature, and humidity. You can also control the entryways and exits individually or all at once by entering the PIN code and using the master lock. You can also control the lights. You can change their color or set it to light up when someone walks into the room. Audio broadcasts can be pre-recorded or live, and also offers directions for the visually impaired. You can also control your power sources from the dashboard. On this screen, you can see solar panels and batteries. And you can also monitor your power consumption.
Team includes Einish, Ebtasam, Max Blee, and myself, Muntasir Syed. Thank you.
Thank you.